I'm super pumped about this lesson because XML prompting is one of my favorite ways to prompt. This is especially good for things like coding tasks and agentic use cases. So if you're doing things like complex AI agent orchestration, or you're doing, complex code editing on entire code bases, things like that, XML prompting is going to quickly become your best friend. So I want to talk a little bit about what XML prompting is, what XML is itself. One of the questions that I get super often is why use XML and not JSON. So we kind of want to address some of the things around that. And then what we're actually going to do in this lesson is we're going to get into a code generation example and kind of show you how to build an XML prompt, how to specify how the AI model should structure its output to fix that format, and kind of what some of the pros and cons of that are. One thing I do want to flag at the very start here is that we do have our prompting course for, let me actually pull this up for you guys right now. Some of you have already taken this, I imagine, but some of you have not. So this, as I drag this in here, this is the Coding with OpenAI, a one course that we did. So this is about an hour. A lot of you watch our videos at 1.25x, which is actually what I recommend. Speeds it a little up. I try and intentionally speak a little bit slow so that you guys can kind of follow along. But if you watch this at 1.25x, it's gonna be a little under an hour. It's a good use of your time if you're very interested in XML prompting. So this is going to be more towards people who are like power users, people who want to build AI agents, people who are like software developers that want to get really complex results out of LLMs, specifically out of really powerful models like OpenAI's O1 Pro. At the time of recording this, this is mid-January of 2025. So we do expect over the next probably 3 to 6 months to start seeing other AI labs outside of OpenAI to probably have some more takes on reasoning models. And the reason I bring up reasoning models like O1 is because, and we will perhaps see this, we'll see what kind of results we get as we play in the playground. But what you'll notice, and this is where using different models is really going to come into play in conjunction with prompting, because in order to get the model to reliably output really complex XML formats, you need a more powerful model. So if we were to go into the playground here, for example, and like switch this to, GPT-4o Mini, 4o Mini is probably not going to be able to handle this. And if it is, it's going to be not that often. Something like 4o might be able to handle it on smaller contexts, but you really are going to want to use reasoning models like O1. Okay, so we have OpenAI, O1 right here, which is what we're going to be using today. We're even going to be using O1 with high reasoning. Please note that if you are following along with this step by step, O1 with high reasoning is a very, very expensive model. So you may want to try this on 4o. What we'll actually do, we're actually going to switch to 4o to be a little bit cheaper to start. And my hope is that it actually does fail so I can show you guys why using something like O1 is needed. You just need more powerful models to handle both the complexity of context length that we're going to be working with and kind of the complexity of the output format. So when you're working with things like XML, you're going to need a more powerful model. Like, for example, if some of you are following along, say, in the Anthropic Workbench, Claude 3.5 Sonnet, if I pull in Workbench here from Anthropic, right? This is Anthropic's playground. We talked about this in the tools section of this course. But this is a model that is a bit cheaper, and it's still one of kind of the more standard LLMs. Claude 3.5 Sonnet is not a reasoning model, and this is going to be able to handle XML pretty well, not as well as O1 with high reasoning. But if you kind of want something in between 4o and the O1 models, it's a little cheaper that you can play around with. I do recommend 3.5 Sonnet. Pretty good model for this. But just to get back to this course really quick, kind of went on a tangent there. This is a really good example of a practical problem that XML prompting solves. And not only do we go into the prompt, but we go into kind of how to use the prompt with actually writing code. And we also talk about, which is very important, one of the big reasons you want to use XML prompting is because you can get XML parsing, which is basically the model's giving you back structured output. And so you can use an XML parser to basically parse that structured output and get the information that you need. And so the great thing about this course, even if you're not interested in this particular problem, it's still a very good overview of that entire process. So I do recommend, if anyone is watching this lesson is like, wow, I'm like really infatuated with XML prompting, I have some ideas, this is a really good course that we offer that may be worth your time to go watch after this lesson. But let's jump back into talking a little bit about what XML is. So XML is basically just, if you're familiar with HTML, right, which is kind of the way that websites are structured and things like that, it's very similar to HTML. XML stands for Extensible Markup Language. You'll see it even says it's similar to HTML, but XML doesn't do anything. It's basically just semantics. So you can name these tags anything you want, which you'll kind of see us going about as we get into writing our prompt in just a second here. And basically each XML tag pretty much has an opening tag and a closing tag. And inside of those tags, you are able to define some sort of structure with other subtags. What happens is all of these tags, and because of the sort of semantic flexible nature of how you can name them, you're able to get pretty clever with them. And the best way to actually demonstrate this is really just to show you. So in this lesson, we are actually going to be looking at a prompt that's very similar, if not, actually, I think we'll just use the identical prompt that we use in the Coding with OpenAI 01 course, just because I think it's a really good introduction. So let's actually just start writing that prompt, and then we'll kind of elaborate. Let's actually get going on something actionable here. So what we're going to do here is we're going to start doing our prompt. You'll notice that I'm not adhering as much to kind of the anatomy of a good prompt framework that we talk about all the time here. This is going to be a little bit more freestyle, and this is sort of an artifact of both how you do XML prompting and the fact that you are typically going to be doing a lot of usage with XML and reasoning models. And the way that you prompt reasoning models is just a little bit different than traditional LLMs like a GPT-4o, which we touched on in the using different models lesson from the previous section. So you may, if you skipped over that, you may just want to check that out really quickly. We also have that lesson on using reasoning models. So those two lessons kind of touch on some of the nuance between how you should be prompting kind of standard LLMs versus how you should be prompting reasoning models. But what we'll do is we'll just say present a complete plan. You know what, let's actually do? I'm just going to paste the entire thing. Then because we're not really trying to iterate on the prompt itself. We just kind of want to explain it. So what I'm going to do here is I'm just going to paste this entire thing in, and I'm going to talk about what's going on here. So this is going to be the entirety of the prompt here. And so what we will be doing on our end is talking about what's going on here. Okay, so this is pretty similar, okay, to what we've been doing in other lessons, right? We're basically defining the task, which is that we want the model to present a complete plan to solve the problem and implement it in the code base. Okay, so we're tackling a code generation use case. That's kind of the basis of our prompt here. And the idea is that we are going to be providing context of the entirety of our files. So you'll see what I do with that in just a second, along with our request. And the model is going to take that request and it's going to take all of the context it has over our code base. It's going to figure out what plan we need to solve the problem and how to implement it. And then at the end of your response, okay, so we're defining output format at this point. At the end of your response, respond with the following XML section. And then you can see here we do XML section. And the first thing that we do is we kind of define a few rules, okay? So we've talked about sort of the details and rules and requirements area and how sometimes ordering those as a list of bullet points is really helpful. So you can see we're doing a bunch of stuff, right? We're saying do not get lazy, always output the full code in the XML section. In case we're just saying, hey, AI model, like don't do anything where you do comments and you say like, okay, rest of the code here. Like you need to output the entirety of the code. The section should be enclosed inside of a markdown code block. All the files should be included, and this is where things get interesting, and this is where our prompt and how we're kind of writing the requirements is going to tie into how we're writing the XML. So before we look at the rest of these rules right here, I actually want to jump immediately into the XML. So what you'll notice is, and let me actually just zoom in just a little bit here so it's a little bit bigger for you guys. So what you'll notice is we basically have one big code_changes tag. So in XML, you kind of use these arrows, these arrow brackets to sort of box things in. Again, you can kind of go into the XML page that we linked here, and you can sort of see all the Lego ads. Get distracted there. Got to be careful with these ads. But you can kind of see sort of generally how XML works, right? Again, the opening and closing tags. So in this case, we have code changes and a closing code changes tag. And then everything else is going to be enclosed in here, okay? And then wrapping our code changes, okay? And the reason we name this code changes is because we semantically want to sort of convey to the model what's actually going on here. So if you were, an actual human being or whatever, and you saw this, you'd be like, okay, in between code changes tags is going to be code changes, right? Very self-explanatory. Same thing with changed files. What's going to be in between changed files? I'm probably going to infer that we're going to have a bunch of files. So what you'll see here is inside of changed files, okay, so in between here and its respective closing tag, what we have is we have a bunch of files, okay? And so in our example format here, we're showing the model an example of what one of those changed files looks like, and then we're also specifying that the rest of the remaining files will go here, right? Which is still within changed files. So the idea is like, this is what one file looks like. And then the AMP model is smart enough to infer, okay, the rest of the remaining files will go here still inside of this changed files XML tag. So let's look at the file tag here. So inside of file, we have a couple different things. We have file operation, we have file path, and we have file code. So this is where, if I zoom back out a little bit, this is where the different, the rest of the rules come in. So you'll see one of the things that we want with each file is we want each file operation to have either a create and update or a delete. Okay, so that is what file operation is. This is going to be either create, update, or delete between each one of these tags. Okay, so we've defined the XML structure for that. And this is going to be useful because at the end of it, right, we're going to basically be able to write some code that can parse it, which is beyond the scope of this lesson. We're just showing the prompt and the resulting prompts. If you want to get into the parsing stuff, again, go check out that O1 coding course. That's going to cover all of that kind of stuff in detail. But then you'll see for create and update operations, we want to include the full file code. So you can see one of our tags is file code. You can see here's its respective closing tag. And then inside of here, we have the full file code here. And you'll see this weird thing, this CData thing. This is a quirk of XML. So one of the things that can happen if you're doing code generation requests with XML is if you use this kind of weird CData syntax here in between these double brackets, it basically just helps with output parsing. Because one of the things that can happen is because, for example, if you're familiar with React or HTML or something like this, you're going to have inherently in that code you write sort of XML tags within it. And so it just kind of helps the parser understand that, hey, whatever is inside of these tags is XML that's separate from kind of the quote unquote parsing XML that we're using. So that's kind of what that weird tag is. If you're confused by that, I recommend checking out the O1 coding course goes a little bit more in depth there, or just ask an AI model and it will quickly get you up to speed. And then you can also see one of our rules here, include the full file path relative to the project directory. So we're getting very specific on what kind of file path we want to remove any ambiguity. Okay, so this is kind of the door rule in practice here. We're trying to just be really specific about what kind of file path, and then you can see the file path is defined by file path tags. So what we're going to do here is we're actually going to test this thing out. I know that this is a lot of jargon, especially if you're somebody who's not a developer. Developers are able to get this pretty quickly because they're familiar with syntax that looks like this and things like that. If you're not a developer, don't worry. Being a little bit lost is fairly normal. Just kind of keep sticking with it. This is one of those things that's going to really crystallize in your mind the more that you try things. So what I'm going to do here is I'm actually going to paste this giant. So if I kind of scroll through here, this is just a bunch of code from one of my code bases. This is actually the O1 XML parser. This is an open source code repository that I have on my GitHub page. This is covered again in the O1 coding course. This is almost like an intro course to that course. That's kind of what this lesson's turning into. But what we're gonna say is, please make a really nice looking welcome page. Just a pretty generic request, just so that we can get something going. And what we'll do is we'll go ahead and run this. So the model you're going to see is going to actually begin by responding with a plan. Okay, so why is it actually responding with a plan? So the reason it's doing that is because if we go back to our prompt, the very first line in our prompt is present a complete plan to solve the problem and implement it in the code base. So the model is interpreting that as okay, I am gonna kind of explain my plan here. I've got to scroll again. That's a really long token request. So you can see this area is kind of the plan. So you can see it's like, okay, it needs to update the root layout, needs to update the welcome page, do some style enhancements, consider adding animations, and then you'll see it kind of does the implementation, and it looks like the model is actually handling this pretty well. So this is probably because we're not using as many tokens as we would typically use in a real world workflow, because this is kind of a mock one. So because the complexity of the use case is pretty simple, and because the amount of context we're using is fairly low, you can see this is, it's only about 5,000 tokens of input and then 1,700, more like 1,800 tokens of output. Pretty small request. In my actual real world workflow, it's much more common for me to use a model like O1 with high reasoning enabled, and I'll do something that's literally like 100,000 tokens and I'm getting like 5,000 tokens of output. So a model like 4.0 just can't handle that scope, but for the purposes of our demonstration here, it looks to be fine. So what's going to happen here, and this is a little bit difficult to read just because of how long this is, but if we scroll to the very top of the output section here, you'll see we get the 3 backticks with XML. So this is in Markdown. This is a code block format, which is what we defined in our output format in the original prompt. And then you can see it's actually formatting that response as XML. So you can see we're getting that code changes tag, we're getting that change files tag, and then inside of the file tag, we're getting things. Okay, so it looks like we're getting file summary. I actually don't, did I have a file summary here? Okay, so this is interesting. So unless I'm like totally just missing something, we actually shouldn't be getting a file summary tag, which is interesting. So this is almost 4.0 kind of getting something that's wrong based on the exact format that we want. But you can see if we go all the way back down here, you can see we are getting the file operation here. We are getting the file path, but you'll notice the file path that we're getting is the incorrect format. It's not the, or actually it might be. I can't actually remember what it is in this prompt. Okay, so you can see good. It actually was giving us the good prompt format. This is a reminder for myself to make sure I review the prompts that I'm supposed to be talking about here. Sometimes these things get a little crazy when I'm doing this off the top of my head. So, and then you can see, of course, inside of the file code tag with the seed data, let's actually drag that, we're getting the updated code for each file. So what's basically going to happen is it's going to do that. So you can see this is a closing file tag. Then it begins opening a new file tag, and then we have a new file here. So we're getting the file operation. So this is an update on the file at this path. And then this is the code that it should be updating with. You can see we're getting another file here. So what's basically happening is the model is taking our request, it's taking the code base we fed it, and it's applying all of those changes based on this sort of pattern. And the reason we would use XML for a use case like this is because at the end of it, what we can do is we can parse each one of those different tags. And then if we want to do something like make a GitHub automated pull request, which is, we'll just kind of, if you're not familiar with that is, what that is, I won't go too into detail there. I'll kind of maybe assume that people that are listening to this are somewhat familiar with that. If you're not, maybe go ask a model what that is. So that we can keep things a little bit simple here. But the idea is we can parse that, we can turn that into a full GitHub automated PR, and boom, suddenly we have like an AI coding agent that's able to kind of autonomously handle full feature requests, take that into full, multi-file edits, and then we have an automated PR, right? So you can do really powerful things like that. So that is kind of the gist of XML parsing, or of XML prompting, rather. So I know this is a little bit more complex. So at the time of filming this, we don't have all of our complete agent projects out. In the next 1 to 2 weeks, we're going to have about 4 to 5 different agent projects that really get into how you can use XML prompting for agents in particular, including one of those is going to be a coding agent that's going to do something very similar to what you see here. And that's going to be a little bit clearer on how XML prompting is useful in some of those different use cases. But this is basically the gist, is you want to define some sort of XML structure. The advantage of doing that is that you can then parse it at the end, grab the data you want. I mentioned that I was going to talk a little bit about why XML prompting is nice versus JSON prompting, and JSON just isn't as flexible as XML because XML doesn't really have a set format. You can be very verbose. You could write entire sentences between these tags. You can even do different values. So I could do like, I'm trying to think where this would make sense. This would be like name, and then you could put like, file name here. You're right. There's just a lot of flexibility with XML. And because the parsing is honestly just about as easy as parsing JSON, it's going to end up being really useful, especially when you're working with really, really long requests. If you're doing simpler things that don't have super crazy schemas or the files aren't super long, like use cases like data extraction, when we actually get around in the next lesson to doing JSON, we'll talk about things like data extraction. That's going to be a really nice use case for something like JSON. It's very simple. It's very clear cut. The documents aren't very long. You're not asking the AI, to write entire code files inside of a JSON file. That's a little messy. It's much better to do something like that inside of XML tags. So hopefully that was helpful. I know, again, this is a little bit of a wonky one. XML prompting is very different than most types of prompting. And a lot of getting better at this is just trying it on different use cases and seeing where it works, where it doesn't, what it's helpful for. But I do suspect that this type of prompting, especially going forward in the future, as we get longer and longer context windows and more powerful models, and as we ask these models to do longer tasks with longer output tokens as well, not just requests that have longer context windows, but things that are inherently being asked to output more tokens, I think the XML prompting is going to be something that you're going to want to be familiar with, which is why we're covering here. So let's shut this one down before I keep rambling. I could talk about XML prompting all day because we actually, I'll even say this is maybe a little bit of alpha, is that we're considering doing a separate entire course on XML prompting. So if that does end up happening in the future, we'll make sure to link that below.